creating a multispectral image from the datasets that you already downloaded. This is lab session 2. But before that, let's have a look at the software that we are going to implement in order to create a multispectral image, as well as in order to create normalized difference vegetation index. So to complete this exercise, you will need ArcGIS desktop, which is licensed version, or ArcGIS student trial software. So you need ArcGIS student trial 1-year license, can be provided free of charge at the following address. You need to be able to give your university account, and you'll be given ArcGIS student trial 1-year license. So from this ArcGIS software, it has 3 product levels: ArcView, ArcEditor, and ArcInfo. This ArcGIS desktop software has also 3 applications: ArcCatalog, ArcMap, and ArcToolbox. We use these desktop applications for different reasons. We use ArcCatalog in order to organize our geospatial data sets, in order to document your content, to create metadata, and the like. We use ArcMap to make maps, to print maps, to compile, to edit GIS database, and the like. So most of the time we use ArcMap. And in ArcToolbox is the 3rd type of desktop application, which includes a lot of geoprocessing tools. As the name implies, ArcToolbox, it's a box for different tools for geospatial processing. So we'll be using these 3 most commonly used application types in ArcGIS desktop. That's it. So let's have a look at the combined composite multispectral satellite image. Okay. Once we download our satellite dataset, the data that we get is usually, let me show you what the data looks like. From a geospatial dataset, I have already stored that dataset, which is a 10-meter dataset. The moment you download it, it looks like this. So let's copy. Let's add these datasets into our ArcMap page. Let's have a look at, each of this is, for example, it is a 2020 January 7 satellite image for this specific location, which is band 8 with 10-meter spatial resolution. This one is also the same year, the same location, but different band 4, band 3, band 2. This is Sentinel satellite image with high spatial resolution. That's why I have chosen to show you this satellite image. So this is what the individual bands look like. So it is very difficult to identify objects, So you need to be able to create a multi-spectral image out of this individual image. So you have single band raster datasets. How do I create a composite, which is multispectral satellite image? This procedure is called composite bands, or creating multispectral bands. Okay, there are 2 options in ArcGIS to create composite bands. There are 2 procedures to create multispectral image. One is in ArcMap, you go to Window and Image Analysis. You can click that button and you can create a multispectral image. I'll show you this. You have Windows, you have Image Analysis, and the moment you open this window, these bands are already there. So based on these bands, you may create layer stacking. Okay, you may have to select all of these data sets, for example this. Once you selected the layers which needs to be included in the layer stacking process, you go to this composite bands. It says composite bands. You click on this. It will automatically create composite bands. Okay, if you click on this. So this is a very simple procedure. So you have to be able to save this layer finally once you are satisfied with the result. Once you make sure that you are very well with this data set, you click on save, okay? And you give a special name and save it, okay? So for the timing, let's save it anyway. So I'm going to save it in satellite image with 10 meter spatial resolution. Let's give a name, which is multispectral, for example, with image. You can save it. The software is processing the operation, so we have to be patient until it brings some information. And it is processing. Okay, it will ask you, would you like to add the exported data to the map as a layer? If you like, you can say yes, and you have a saved multispectral composite image. So you may remove it. We don't need for the timing. So now I'm going to use another procedure, which is the second option is go to tools and type, this is a search button. If you type composite, composite, it will give you this kind of options. You need composite bands. You need the tool which creates multispectral bands. So you click on this. This is the Arc toolbox. Okay, so you'll find a bunch of tools for geospatial processing. From all this, you don't have to remember all of where different tools are stored. So you just go to the search button, and the only thing that you need to know is the type of operation you are interested in. So give the raster datasets. So if you give band 8, for example, you need to give input layers for the composite bands. Okay, I'm giving band 8 in the red band, band 4, and band 3. You can also include band 2, but for the time being, let's remove it. Only 3 layers are required for making multispectral image, the minimum dataset. Requirement for creating multispectral dataset is 3. You can include 4, 5, 6, 7, 10. and the like, but it will take more time as you add more layers. So you have to save it here, satellite image, and multispectral, procedure 2, open 2. So I just click on it. So we have to be patient and wait for some time. Okay, it seems that the operation is already completed. So it gives you similar results. This is also a composite band. It's a multispectral band. Okay, this is called a false color composite band. You know, there are different band combinations in creating multispectral composite bands. For Sentinel, there are different combinations in red, green, blue. For Landsat, there are different combinations. For example, if you combine band 4, band 3, band 2 from Landsat 4, 5, 7, then you will be able to create a false color infrared image. You can also create a natural color image. If you combine band 3 in the red, band 2 in the green, band 1 in the blue color gun. If you have Landsat 8, band 4-3-2 combination will create natural color. Band 6-4-5 combination will create false color. Again, this is also false color, this is also false color. So when you come to Sentinel-2, different band combinations in the red, green, blue combinations, what does this red, green, blue means? If you click on ArcGIS and click this, double click this image, you will have red, green, blue. So you can select which band are you going to display in this color gun. I'm going to display band 1. In our case, it is band 8. Red, it is band 4. Blue, it is band 2. So this is band 8-4-3 combination. Okay, this is what the RGB composite is. So in our case, there are different applications. False color infrared is created when you have band 8 of Sentinel dataset in the red, band 4 image in the green, band 3 in the blue. When you make it 8-4-3 combination, you'll be able to create false color infrared Sentinel imagery. And there are different combinations which might be helpful for identification of agriculture, healthy vegetation, land and water identification, and the like. You can use these definitions. When with regard to the spatial resolution of each of the satellite images, bands, band 4, 3, 2, and 8 are with 10-meter resolution. The remaining are with 20, and there are also 60 meters spatial resolution from Sentinel-2 dataset. So with this, we will finish discussing about creation of multispectral satellite imagery. Okay, we can appreciate that this multispectral image is much better than the individual image. It is very difficult to identify objects in the single raster bands. That's why we are going to create a multispectral imagery for feature extraction, both visually and using computers. Now let's create, this is the end of lab session 2. Now we are about to discuss lab session 3, is about how to compute NDVI from satellite images. We remember that NDVI is normalized difference vegetation index, computed as near infrared reflectance minus rate, near infrared reflectance, rate plus rate. And in ArcGIS, once we have the near infrared band and the red band, we can compute NDVI using this equation, float. You need to have a float. This float describes the data type when it subtracts near infrared minus red. When you do this operation, the output of this should be float. This is a data type, because the nature of NDVI values will dictate us to make them float. The whole NDVI value ranges from -1 up to 1. In between there are decimal place numbers, and so most of the values are decimal place, just like this, 0.2, 0.3. These are floats. Okay, in order to make your NDVI value float, you need to specify this in the raster calculator equation. Okay, so if most of the time negative NDVI values are clouds, water, or snow, near zero NDVI values indicate rock and bare soil, and very low NDVI values, just like between 0.1 and below, are rock, sand, and snow, and moderate values between 0.2 0.3 may represent shrub, grassland. But oftentimes NDVI values with greater than 0.4 0.5 indicate that these are evergreen forest or woodland, dense woodlands. So the application of computing NDVI is, it has a lot of application. So it is often used to monitor drought, to monitor and predict agricultural production or yield in agricultural risk assessment, insurance, damage assessment, and it will also help us in to also assist in predicting hazardous fires, and it will also assist to map desert encroachment, bush encroachment, and there are a lot of applications of GIS. And the next question is how you can calculate you can calculate NDVI. You can compute NDVI through ArcGIS by using Arc Toolbox. In Arc Toolbox, you'll find spatial analysis tool, map algebra, raster calculator. So let's see how you can compute NDVI based on this. Let's remove this. The data that we need for NDVI computation is near infrared and red band. Which one is the near infrared band? Which one is the red band? Is that band 8, band 4, band 3? You should identify this. But in our lecture slide, I have already given you band 3, band 2 is blue, band 3 is green, band 4 is red, and band 8 is near infrared. So band 8 and band 4 are required from Sentinel datasets. This, nomenclature or this naming can be changed if you visit different satellites. For example, in Landsat 8, band 5 and band 4 are required. Band 5 is near infrared, while band 4 is red. But in Sentinel-2, the near infrared is band 8. So you should identify this. You need to have this information before you compute NDVI. So the data that we need for the time being is band 4 and band 8. So we have to remove the remaining one. So this is near infrared, this is red. Now go to spatial analysis, map algebra, calculator. So you have to search float, and make over float. Inside this, you will insert near infrared minus red. So this minus this. Inside this as well, this plus this. Now give a name for your output datasets. I'm giving a name NDVI.TIF. So you say OK. You have to wait some minutes, some second, until it processes. Okay, it looks like the operation is completed. Now let's explore what this NDVI value is. Okay, let's give another, maybe color is usually subjective. So we can select our own color, but for the time being, let's use this color. And let me change it again. Yeah. This is the NDVI value, which ranges from generally from -1 up to 1. Okay, you have different values. Let's give a category, classify into probably 5 classes. Okay. Now we can have this color. So let's give a proper, classification category. There are values which are less than 0, and there are values which are less than 0.2, and there are values which are less than 0.3 and 0.5. Let's examine the dataset that we have. And what is this feature? It must be a water body. It must be a dam. In order to investigate this, you need to have a background image, which we did already. Okay. So let's make it 4, 3, 2 combination. Yeah, now this is false color. So this is a water body, and if we examine, and this is forced, and the value of NDVI is greater than 0.5 since it is forest or woodland. And this one is a water body, the NDVI value is less than 0. And this is agricultural land or grassland. The NDVI value is very much closer to between 0 and 0.2. Okay, so the NDVI value is telling you the nature of the area. For example, this is urban area. Okay, this is urban area. Its NDVI value also varies depending on the material present in this urban area. For example, this is a runway for airplane. This is what it is telling us. You can also have a different view by adding effect and create a sweep. Okay. You can also make this kind of operation, and you can investigate. Even this can detect the different vegetation types in urban area. Okay. So this has a very useful application. So thanks for watching.